Alright, this video is going to cover section 2.4 from your textbook over linear inequalities in two variables. What we've been doing with linear equations so far is, well, we've done several things with them. But for one thing, if we want to draw a graph of an equation of a line, we should know how to do that at this point. We start, if we have our equation in slope-intercept form, we start at the y-intercept. So let's say 1, 2, 3 is up here. I'm drawing with my fingers, by the way, so this is not going to be very neat. And then the slope is 2 over 1, so we're going to rise 2 and run 1. Okay. And then if we want to connect the dots, there's our equation of our line. Okay. The slope is positive 2. The y-intercept is positive 3. And there's our equation of our line. Now what we're going to be doing today is we're going to be doing linear inequalities. So instead of an equal sign in our problem, we're going to have a less than symbol or a greater than symbol, or maybe your equal to symbol in the problem. Ooh, sorry. So let's say that we're given the inequality y is less than 2/3 x minus 4. The first thing I'm going to do is just like I would in terms of graphing an equation, a linear equation instead of an inequality. We're going to start at the y-intercept. Let's say 1, 2, 3, 4. Y equals negative 4. And the slope tells us to walk up 2 and over 3 to get to another point on the line. Up 2, over 3 to get to another point on the line. Then we can connect the dots. And there's our equation of our line. Let's make a match. Okay. Now, when we're dealing with inequalities, when we were back in chapter 1 on our last test, we know that when we were drawing graphs, there was a difference between how we graphed x is less than 5 and x is less than or equal to 5. And when we were in one dimension, that difference came down to parentheses or square brackets. And in the symbols, we understood that if we saw parentheses on a graph, that the number 5 would not be included in that set. But if we had a square bracket instead, then that means 5 was part of the solution set. When we're looking at an inequality with two variables now, with the x and the y, there's not really a way I can use parentheses or square brackets, either one, on my line. So the way that we deal with that, the equivalent, if my fingers will work, is if it says less than or greater than, instead of less than or equal to or greater than or equal to. The way that I know to stay off of that line is I make it a dotted line instead of connecting the dots and making it solid. So there's one part of my graph. First I get the line graphed, y equals 2/3 x minus 4. And if the inequality symbol says less than or equal to or greater than or equal to, we connect the dots with a solid line. If it just says less than or just says greater than, then we connect it with a dotted line instead. Now the next part is that I have to try to figure out whether my solution set is up above my line or whether it's down below. Because the solution set will actually be on one side of that dotted line or the other. So the best approach to take is to choose an ordered pair that is not on your line. So for example, maybe the point 1, 1. It's not on my line. And I'm going to check and see whether or not it satisfies the inequality that we started with. So if I plug in 1 for y and 1 for x, I have to determine whether this is a true statement or a false statement. Okay, this says 1 is less than something that's negative. 2/3 minus 12/3. Positive 1 is not less than anything that's negative. So if the point 1, 1 does not satisfy that inequality, that means it's the other side of the line where the solution lies. So I pick an ordered pair that is not on my line, and I'm going to plug it into my inequality. If it satisfies the inequality, I'm going to shade that side of the line. Since it didn't, my purple dot didn't satisfy the inequality, I know I'm standing on the wrong side of the line. So I have to go to the other side and shade over there. Let's look at y is greater than or equal to x plus 3. Now my first step is to draw a graph of that line. Pretend that it says y equals x plus 3. So if I go up to a y-intercept of 3, I am right here, 0, 3. Pretend that hit 0, 3. And my slope is 1. So I rise 1 and run 1. Rise 1, run 1. Okay, so on up the ladder there. Now if I want to draw that line, I'm going to connect those dots. I'm going to turn it blue so it matches. And this time, since my inequality symbol says I can be equal to, y is greater than or equal to x plus 3, I'm going to connect that with a solid line instead of a dotted line. So I know that I can actually stand on the line and be part of the solution set. Okay. Now I'm going to pick an ordered pair that's not on my line. So again, maybe my favorite point to pick is the point 0, 0. So I'm going to plug it into my inequality. 0 for y, 0 for x. That says 0 is greater than or equal to 3, which is still not a true statement. Okay, next time we'll pick one that works. Since 0, 0 did not work, that means my solution set is actually on the other side of this line. So I'm going to shade above that line this time. Okay, the graph, there's no interval notation in this section. You simply draw either a solid or dotted line and shade one side of the line or the other. Line 2x minus 3y is less than 6, and I want to graph the solution set for this inequality. The first thing we need to do is put our equation of our line into slope-intercept form, meaning I want to get the y all by itself on the one side of the inequality. Now notice when we do that, first we subtract the 2x, and then we're going to divide both sides by -3. Don't forget that when we divide or multiply both sides of an inequality by a negative number, then that means we get to switch the direction of the inequality symbol in that step. Negative over negative gives us positive 2/3 x, and 6 over -3 is -2. Therefore, when we go to draw a graph of this line, we're going to go down 2 steps on the y-axis to get a y-intercept of -2. The slope says we're going to go up 2 and to the right 3. And there's our other point on the line. Okay. We'll connect the dots. Turn it blue. Also, because the inequality symbol strictly says greater than instead of greater than or equal to, we need to be sure that we make our line a dotted line, so people know that they have to stay off of that line if they want to satisfy that inequality. We're then going to choose an ordered pair. The ordered pair can be anything that's not on that dotted line. Again, I like 0, 0 because arithmetic with zeros is the nicest arithmetic to do. But you can pick the point 1, 1 or 2, 7 or -3, -3, anything you want to choose that's not on that dotted line. The safest place to plug it in is to take it all the way back to the beginning. That way, if you've made a mistake in one of your middle steps here, you're going to be more likely to catch on to that. When I plug in 0 for x and 0 for y, the statement comes out 0 is less than 6, which is a true statement. Since my point 0, 0 satisfied the inequality, that means I'm standing on the correct side of the line this time, and this is the one I get to shade. Okay. So the solution set will look like what I've got there, that scribbled mess. Dotted line, shade above it. A lot of students like this section better than the ones with the one variable, a little more straightforward, hopefully. Solve for y, graph your line, solid or dotted, shade one side or the other. The exercises I want you to do from section 2.4 are as follows. Go ahead, I'll post these, this on the blah, 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 blah.